moving along, we need to look at anchor points, okay? How do we, these are great. This tells me how to get the webbing into a loop. It tells me how I'm going to utilize the rope, but I need now to start hooking it to stuff. Anchor points are the foundation of what we're doing. That's the thing that I need to have to build this whole operation. So it would be good, first of all, to be able to select anchor points. It would be great if I could have a little checklist of characteristics that I'm looking for, all right? What are the things that I'm looking for when I choose an anchor? So let me throw that to you guys. If you were going to say, hey, look, I'm going to throw you over the side of this 20-story building, what do you want me to anchor the rope to? What are the qualities or characteristics of the thing you want me to hook it to?
Something heavy.
Stationary?
Something heavy. Okay, let's go with that. Something that has mass. So you got a 5,000-pound chunk of concrete sitting here. That'd be good. I like that. 5,000 pounds. I like that. Okay, something that's not going to damage our equipment, or at least provides me with a way to protect my equipment from it. What else? Some of the other guys threw out some other stuff.
Some stationary?
Okay, I want to look at how it's attached or connected to the building or to the earth or something like that. That 5,000-pound chunk of concrete, if it's laying here on loose gravel or on pipe rollers or something like that, or on the slope of a hill, 5,000 pounds isn't looking all that great to me anymore, right? It could still move. Those two concrete slabs, or those concrete slabs you see laying right over there, we did a little operation here last month, and we actually moved those slabs with the weight of just the weight of 1.5 people hanging on there. Actually, it was one person moved that slab. So it takes more weight than you think to resist some of that movement. Okay, so solid connection, has mass, doesn't damage our equipment.
Won't break?
Yeah, it's in good condition. You know, I don't want something that's all rusted up or all cracked or broken. Okay, so I want that. And then the other things that we need to start to think about a little bit are, what's the application? What is it I'm going to do with it, and how am I going to load that thing? Okay. So in support of that, let's take a look at a little example over here. Come on over this way. You can see that it's just a little kind of a barricade, if you will. You probably see lots of these sitting outside of something similar to it, marking doorways and things of that nature. How's this thing connected to the ground? This is just attached to the ground with a couple of concrete anchors, right? So it's not a great thing, super great thing, but it's not too bad, okay? Well, when I load this thing, if I'm going to put a rope system onto this, and I'll use an anchor strap here as our demonstration, I can pull on this thing in a number of different directions. I could pull, for example, at the top, pulling that direction, right? I could attach at the bottom here, closer to the base, and pull the same direction. Go ahead and out that direction again, okay? Of those two, which of them is going to be stronger? In other words, which ones are the anchor going to be able to resist more force? Why is that? Okay, when I'm pulling at the top, I have a giant lever that I'm pulling and I'm trying to get those out. Yes? Okay, so what he's saying, what he's noticing is that when I pull up here, I'm sharing some of the strength on this other leg, right? As opposed to down here, where I'm really just pulling on one leg, okay? So there's definitely an advantage there, and you'd have to be a little bit of a physicist to figure out, does the mechanical advantage that's prying this thing out of the ground, is the two connection points better even with this working against you, or is this better? I don't know the answer to that. I think this is better. I think that is better. Okay?
You're pulling when you're pulling at the top, you can actually pull them out
Correct.
easier than pulling from the bottom.
Because do you see that when I pull on this up this way and pull that way, isn't that like a hammer pulling a nail out of a board?
Exactly.
Okay? So I'm trying to attach it to base. Now let me ask you this. What about if I pull this direction? If I pull straight down?
Well, that's perfect.
Now it's even stronger in this direction, is it not? Because what impact do the fasteners, do the bolts have on this? None. They could not even be there in this thing. I'd never crush this thing into the ground until I bent this pipe, right? So the whole point here is to illustrate that this anchor might be great in one direction and lousy in another. We have to put that into our assessment of choosing anchors, whether I'm going to use it or not going to use it, okay? So that becomes part of that process. Questions on that? Good?